Warm greetings to all our online viewers and participants, and welcome to our keynote session by Dr. Mila Koeva. Dr. Mila Koeva is an assistant professor in 3D land information at University Twente International Institute of Geoinformation Science and Earth Observation, ITC, the Netherlands. Her main areas of expertise for teaching and research include photogrammetry and remote sensing, which includes satellite, aerial, and UAVs, digital twins, smart cities, 3D modeling, 3D cadastre, surveying, GNSS, and automatic feature extraction for cadastral mapping and urban planning, among others. She's also the guest editor of the special issue Remote Sensing for Land Administration 2, co-chair of ISPRS Working Group 4, reviewer board of ISPRS, IJGI, that's the International Journal of Geoinformation and Geomatics. She also takes to her credit coordination of a 4-year multidisciplinary European Commission Horizon 2020 project, It's for Land, involving 8 academic and private sector partners and 6 countries in Europe and Africa. Dr. Mila Koeva will enlighten us today on the topic, UAVs for Land Administration, Best Practices. I now request Dr. Mila Koeva to please share her knowledge with us.
Thank you very much, dear Esther, for the nice introduction. And thank you very much for all of you for inviting me to be a keynote speaker for this international conference. It's really a pleasure for me to be among you. I will share with you a little bit of our experience with UAVs for land administration and what we have done in the past 4 or 5 years related with UAVs. I will start with our motivation. How did we decide using UAVs in general for land administration? We got inspired by the fact that 70% of land rights in the world are not recorded, and we were searching for solutions how to speed up this process and to record these land rights in a more accurate, fast, and cheap way. And especially in sub-Saharan Africa, this percentage is only 3%. So we were focused on those countries. As in the introduction was said about me, I was leading a big project in the last 4 years, which is called It's for Land, and I'm quite passionate about it, and I would like to share some information with you about this project. It incorporated 8 partners from Europe and Africa, and if you see on this screen, in the red circle is the part which was dedicated for UAVs and UAV flights. So it's a small part of the whole project, but a very fundamental part because it is acquiring the main source of data. So to make it more efficient, I will show you a video about the project because the time is limited. And then we will continue talking about the UAVs.
In developing regions, over 70% of land tenure rights are neither mapped nor recognised. Land rights recording gives landowners tenure security, sustainable livelihoods, and increases financial opportunities. Challenges can be overcome with innovative geospatial technologies. Therefore, the It's for Land project developed a unique suite of affordable, fast, and easy-to-use tools to responsibly record land rights. Incorporating cutting-edge software tools inspired by geoinformation technologies and smart ICT innovations, it responds to end-user and market needs. Smart sketch maps transform hand-drawn spatial representations into high-quality maps for GIS usage, allowing non-experts to claim their land rights. UAV technology and drones accurately map areas in less time and at lower costs, allowing communities to map land tenure rights independently or collaboratively. Semi-automatic feature extraction extracts visible cadastral boundaries on the basis of satellite, airborne, and UAV images. A platform that integrates, publishes, and shares data and land recording tools. The interaction between these tools helps secure land tenure rights and positively impacts the government and communities. But the It's for Land toolbox innovations don't stop there. They offer independent services for land tenure recording, such as consultancy services, to assess user needs with respect to geospatial technologies, and governance and capacity development models to allow the usage of It's for Land tools. The international It's for Land team and partners have created a toolbox that supports the fit-for-purpose land administration approach and enables governments, local communities and individuals to record land tenure information swiftly in an affordable way. It's for Land provides innovative solutions through responsible and fit-for-purpose land tenure recording, empowering communities by contributing to their economic security and sustainable livelihoods, supporting environmental improvement, and considering gender equality and social inclusion.
Okay, this was shortly the presentation of the project, and now let's focus on the UAV part. So we developed a UAV workflow that was followed basically for all the countries where we were flying. First, it incorporates the selection of the vehicle. Then we needed to train pilots. Then we, of course, had to get some flight permissions. And then the real acquisition starts, when we have to do the precise flight planning, data acquisition, and data processing. As I mentioned, we start with the UAV regulation exploration, and we had done quite some extensive analysis worldwide. Where are the regulations related with UAVs in place? And this was published from the very beginning of the project, as you can see below. But now we are doing another publication. Soon it will be published with an updated information, because as you can see, UAVs are a dynamic field. So the regulations are changing very often in many countries. So after exploring the regulations, we had to select the vehicle. As you can imagine, 6 years ago, the UAVs were quite expensive. So we selected this fixed-wing UAV that was at that time something like 40,000 euro. Now you can buy UAV much cheaper and with similar, let's say, parameters and qualities. That time we selected the fixed-wing UAV because we wanted to fly long distances, and this one was able to fly 16 minutes without stopping. And of course, it had IMU and GNSS on board, which was giving quite accurate information. And we had to train 8 pilots, which were representatives from all our 8 consortium partners. And you can see here some images from our acquisition time in Rwanda. And here you can see in Kenya, also measuring ground control points. This is so-called Siemens star that we were using. So there were different types of control points. And this is in Zanzibar. Apart from our UAVs, we also used local companies like this one, for example. This is AEB UAV. So basically, we explored the functionalities of many UAVs. I will show you again a short video related with the data acquisition. So here is the selection of the ground control points and measurements of the ground control points. And this is calibration of the UAV. And it's basically ready to fly. Here is in Zanzibar, in Tanzania, with the EB. Here you can see a UAV, which is a mixture between rotary wing and fixed wing UAV. And this is another one, which is only rotary wing UAV. This is our group of people. And on this picture, you see our pilots. For all our acquisitions, we were following the same sequence of procedures like flight planning, image orientation, orthophoto generation, and quality control. And for the flight planning, it was important to set the camera parameters, ground sampling distance, to exactly put the image overlap and the area that we will survey and the time. These parameters, they really depend on the terrain and the local weather conditions in the local area. So we had to adapt every time. We put temporal markers like you see on these pictures for ground control points pre-marking, or we were using some permanent marking, as you can see here in this picture. One important fact was to select the exact distribution on ground control points and to discuss and decide which out of them will be considered as checkpoints, in this case in orange and red. So ideally, we decided that from 5 to 10 ground control points is enough if we have quite a precise GNSS on board on the UAV. Also, we had to decide what kind of processing software to use. We explored a commercial version called Pix4D and also an open source software called Open Drone Map. And now I want to emphasize a bit on the quality of the UAVs for land administration, quality of the data, I mean, the data that was captured. We really emphasize on the composition of parameters that can influence the data quality, and we investigate them in terms of accuracy, reliability, and completeness. We also thought which would be those parameters, like internal parameters that influence the geometric accuracy, and which are those that influence the image quality. So you can see on this slide the grouping of those parameters that we were investigating. The test flights for this analysis was in Rwanda, Kenya, and Zanzibar. And you can see here that for all of them, we were evaluating based on the overlap, about the way of the UAV flight, whether it is a cross track, a long track, the ground sampling distance, the number of control and checkpoints. And you can see also here the different flights and UAVs that we have been using. This is a similar criteria of evaluation for the data in Zanzibar. And you can see the result of this research. It ended up with publications like usual. We have one in the ISPRS conference and one in the Remote Sensing Journal. If you're interested, you can see the detailed results. I will share with you in this presentation only the final results, that in conclusions that we derived. So we had case studies in Africa, in Rwanda and Kenya, and we also had case studies in Europe, in Netherlands and Germany. This was also related with comparison of the different terrain and different weather conditions in those countries. And we explored 5 different UAVs. As you can see, there are fixed wing, rotary wing, or mixed one, with different resolutions and different cameras on board. And as I promised to you, I share with you only the final conclusions. We concluded that the ground sampling, ground control point number matters, and it matters quite a lot. And it actually matters the total number of points and not the number per square kilometer. So this was one of the conclusions. Also, there is quite some relationship between the site overlap and the final error. The final root mean square error. We analyzed also the performance of the two different processing softwares. OpenDrawMap is an open source software, but still is not performing so well as the commercial one. To speed up, just to give you a short recommendation for land administration practitioners, you can really pay attention on the flight planning, the good distribution of ground control points, and the measurements with the GNSS. Another interesting research was related with the stakeholders' perspective, how stakeholders perceive the usage of UAVs. We analyzed that by gaming format. There was a blank radar chart where the participant had to vote and compare 4 different technologies like field survey, UAV-based aerial images, and satellite images. And they were comparing them in terms of affordability, reliability, time efficiency, accuracy, ease of implementation, and open and transparent procedures. You can see here some of the opportunities and challenges that we outlined. It is very good to use UAVs because they allow public participation, they allow independence of data capture, but also there are quite some challenges in terms of GNSS data acquisition and regulatory frameworks are challenges, and also quite a lack of adequate capacity in the countries that we were investigating. If you would like more, here's the publication from the World Bank, so you can read more about the stakeholders' perception. And I would like to finish with the applications of UAVs for land administration. You can see from this slide that providing very high aerial images is quite beneficial for fast data acquisition and also temporal acquisition. And it's relatively low cost solution, but can serve multi-purposes having this high resolution data. We have investigated the final UAV images in terms of what they can serve for. For example, they are very useful for visual interpretation and digitization of cadastral data. Also, it can involve participatory mapping, people which can investigate their properties on a printed orthophoto map. And the last research that I'm quite passionate to mention as a conclusion here is we were very proud of our methods for automatic mapping based on UAV images. We have investigated many algorithms and methods for automatically extract cadastral data out of UAV images. And some of this is this CNN or machine learning method for cadastral mapping detection. So you can have a look at the publication. Overall, I would say that through these years, we have done quite some research in using UAVs for cadastral boundary mapping. And you can see here some examples from Indonesia, Rwanda, China, Zimbabwe. I'm missing in the slide Kenya and Ethiopia, but they're also there. Thank you very much for listening for my presentation. I hope it was interesting for you. Looking forward to your questions.
Thank you, Dr. Mila. We are still waiting for the questions. As of now, we haven't received any, but in the meantime, if you would like to share the most important learning you've had in this 4-year project. And I think we have a question also coming up.
Shall I wait for your question or answer the most important? The most important learning, every country is different. You should really adapt to the local perspective, local rules and regulations, local climate and local perception. We had completely different challenges in all the countries that we were flying with UAVs. Many are let's say, very enthusiastic because in the beginning this technology is inspiring, but when start working, they start seeing that it's not so easy. There are many challenges that should be considered. It's very easy to buy some UAV nowadays and just fly it, but if you don't have enough knowledge about the parameters that you have to set, you may end up with low quality output data.
That's nice.
Question?
Yes, the question which has come to us is from Chandrahas Singh, and he is asking, which camera is best for aerial mapping except DJI-made drones?
This is an interesting question. You know, you have to test the cameras because all the producers are advertising and saying that their cameras are the best, but when you really fly with the UAV, you can see that sometimes because of the motion, some pictures might be blurred, or you can have some other effect. So I cannot say exactly what camera is the best. We're using mainly RGB cameras. Even in our university, we have also hyperspectral cameras, thermal, and so on that my colleagues are exploring. But yeah, you have to try to check always the output of the result, because even with the most advertised UAVs and cameras, we had some issues with the final results. We had to sometimes go back to the producers and ask what is happening, why our images are so blurred, for example. Yeah.
All right, thank you so much. Dr. Mila, we have another question, though the name of the user is not, the name of the questioner is not mentioned, but the question goes by, can we integrate city GML with UAV data for urban planning or LA applications?
Okay. Interesting question. City GML is markup language that is used in city modeling, and it relates mostly to vector data or geometric data. So for example, in Netherlands, if you are interested, I can share with you a link where you can see that the whole Netherlands, you can download open source, freely available city GML data with the level of detail 2, if this is familiar for you. So this means not only the boxes of the buildings, but also together with the roofs. And this is a development which has been released in April. So it's really now from 1st of April, very soon. But this doesn't incorporate image data. So CityGML in this way, it is incorporating point cloud data for the terrain and the footprints of the buildings, the outlines of the buildings, so the geometric data plus point clouds. I have not seen a research which is incorporating UAV images in this way. Maybe there is, but not in this combination.
Right, right. Thank you so much, Dr. Mila. And I think we have another question. It is from Abhishek Adhikari, and he asks, is the cadastral mapping of areas with no visible boundaries, that is, the boundaries which are hidden due to vegetation cover, possible?
Very nice question. This is always within our research, because cadastral boundary mapping is a field where there are a lot of hidden challenges, especially because it's related also with the legal rights, and there are some boundaries that are not able to be distinguished in images. This is exactly what the participant is asking. So basically from space, from image data, we can define automatically or manually only the visible boundaries, or those that are, for example, outlined with some concrete walls or metal walls. If there is ambiguity between the boundaries, if there not visible from the image, of course we cannot derive them. What are we doing as a process is to detect all possible visible boundaries, and then via participatory mapping we are defining, are they really true or not, what is missing and what is not missing. So the communities are drawing on top of the printed orthophoto image with already predefined boundary lines, and then the expert can approve or decline. So the process of automatic mapping from images stops to the moment where you have some boundaries without any legal information added to these boundaries. So you give these outputs to the experts, which can really speed up very much their work. And our aim was, let's say, to help them about 80%, to speed up 80% of their boundary extraction, which is a lot for their work, but still is not fully automatic. Because, as you said, there are many boundaries that are simply not visible in the images. And these differ per country. I didn't mention in this presentation, but you had the research which was comparing how many of the boundaries are visible from images. And we compared countries like Nepal, Rwanda, Kenya, Ethiopia, Indonesia, and so on. And we found out that there are really countries where you can simply not recognize any boundaries from space, from a distance. Like in Nepal, for example, the terrain was so strange and complicated that this method is simply not the working one.
Thank you, Dr. Mila, for the answer. We have another question from Dr. Saurabh Vijay, and he asks, do you encourage your graduate students to become certified drone pilots before doing science on Earth observation related themes, or learning by doing approach?
To be honest, recently, in the last 4 or 5 years, there are quite a lot of young students that are inspired by UAV technology. And to become certified pilots is a bit a strong word, but we are encouraging them to use this method where it is suitable. So there are so-called fit-for-purpose elements and fit-for-purpose requirements. It means that if this method is fitting the purpose of your work, why not? So it's not applicable for everything. But if this can solve your problems in your country, and if it can speed up the processes of mapping in a more affordable way, why not? UAVs are very, very useful for small areas, for example, for map updating. But also there are some disadvantages if you would like to really cover a whole country. So still, satellite and aerial images might be more beneficial. So we are encouraging the students to look at the innovative technologies, and if they fit their purpose, of course, we give them the choice to choose and to develop themselves more.
Thank you, Dr. Mila. I think that would be the end of all the questions.
Okay.
And I also would like to thank our online viewers and participants as well. So we will end this session now, and we look forward to all of you joining us for the next special session on UAV application in water resources at 2 p.m.
Thank you very much.
Thank you. Dr. Mila?
Yes.
Thank you so much for that very enriching session. I would just request you, actually, our professor would.
You want the slides?